안녕하세요.
안녕하세요. 저희 목소리 들리나요?
네, 잘
네.
들려요.
네.
Hi, Francois. Hi.
Good evening, good
Yeah,
morning,
good
good
evening.
afternoon,
Yeah,
wherever.
how are you? You have been so busy, right?
Yeah, I just arrived from 5 weeks at the symposium in Baie-Saint-Paul. Now I
Uh-huh.
have a little cold, so excuse me.
Yeah, I mean,
Yeah, it's the morning and I have a cold, so
uh-huh. Yeah.
sorry about that. Yeah.
Louisa and Sunjung got a COVID.
Ah,
So,
okay.
yeah.
Super. I wonder if it's that, so take care of yourselves.
Yeah, right. Before come to the residency, I mean, you guys,
Exactly.
yeah, should,
Mm,
I mean, prepare and protect yourselves. Yeah, right.
exactly.
Yeah. And
But my
um
kid said it's not positive. I think it's over right now.
Okay, good. Mm.
but but is it okay to have a presentation today?
Yeah, yeah, yeah.
Uh-huh. Okay. Yeah. Everyone's sick. Yeah. Because these days are the weather are very getting cold. So yeah, I can guess. How's the weather in Korea? Is it too hot still?
Yeah, it's just still hot,
Oh,
very hot.
uh-huh. What about Amsterdam? I mean, Sonju?
Hi.
Hi. How's the weather there?
Weather is like cold and hot and cold and hot.
Uh-huh.
Hot and cold. Right now it's a bit warm.
Uh-huh.
Yeah. At night it gets cold.
Mm-hmm.
Yeah. It's getting cold now.
Mm-hmm. So, maybe we need to wait for Marisa and Louisa and Marie and Bob. So actually, I do love I before getting started the presentation, I'd love to share some of the information about the residency. And so we are gonna visit the museum, Canadian Museum of Nature on 13th. So from maybe at afternoon to 5 p.m. And then actually Francois is considering to have his own workshops during that days because I mean because we can visit the Gatineau River when we are getting back to the getting back from the museum to our place. So we can develop your workshops after that. Okay.
Yes, well, yeah. Well, for that workshop, I was a bit concerned about, disturbing a fragile environment
Right.
with a group of 10, or I don't know how many will be. So, but Louisa kind of pointed me to a location that could be interesting next to the covered bridge. So either on our way to the museum or on our way back. Well, we'll discuss more about it later on,
Yeah.
but I think it could be interesting. So we'll see how it goes, but that's the new direction, let's say. But yeah, I'm also concerned about, treading lightly,
Uh-huh.
when I'm by myself, I feel that I'm disturbing the environment. So if we're a group, it could be a bit,
Too big to
damaging. So,
yeah.
so we'll see. But I think Louisa has a good propositions of places that we could go. We'll talk more about it later on.
Right, right.
Thank you.
Yeah. And then actually I had a meeting with the Paul, who is the charger of the museum, that he said we can see the archiver of the collection of the museum for an hour, and then we can have a group discussion, group meetings. We are gonna separate the groups in maybe 3 or 4. One will be members. It's for the Make Lab actually, and then memo part and micro microbes, and then C part, and yeah, this kind of 3 or 4 section groups. So when we I can hear some sound. Yeah, so after we make narrow down the plans, then we are gonna send you the emails. And then actually when we visit there, the researchers wanna hear some of the content. I mean, at least what we have. I mean, what the artist focused on their theme. So that because they want to help or they want to give some resources about that. So if you guys can prepare some 5-minute not the presentation, but you can share your researches more focus, I mean specific research theme with them. So yeah, I want to share that one before we are getting there. Okay. Okay.
I have a question.
Uh-huh.
Is the museum in Ottawa, or where is the museum?
Yeah, Ottawa.
Okay,
Uh-huh. So
an hour drive
yeah,
from the farm,
yeah.
and then okay.
The Bob will drive us, and then the Riza has a car. So yeah. And oh, actually, I don't know why Luisa is not coming. Okay. She left a message. She got a COVID a few days ago, so she will join the meetings a few minutes later. So then just start. So for today's meeting, Maurice and Francois and Sanjung will gonna have a presentation. So who wanna do first?
I can, unless you want to begin, Sanjung.
Yeah.
I can start. So yeah. So I didn't know who would be here. You know, I know like people from the farm, they don't know my work, so didn't know exactly what to prepare for this meeting. So I'll do a quick overview of work I did in the past, and after we'll follow up with my most recent research. So I don't know. Is Mary or anyone from the Farmland Torn gonna join this morning? No.
Pardon?
I'm right here,
Yeah,
and I'm
Mary
right
there.
here. Bob's on his way.
Okay. Great. Perfect. Yeah.
Here he is now.
Yeah, because otherwise I feel I'm gonna repeat myself if I go through my work. But I did a really quick. Okay, I'm gonna share my screen. Hi. Okay, so you see this image. Okay, I'm gonna start. Just a quick recap of my work and of the past years, and I'm gonna lower the volume a bit. So yeah, I've been working a lot with photogrammetry, 3D scanning of different locations. And this was a work called Derive, which is point clouds of different locations that are transformed by environmental data. So the work is in constant flux, constantly changing depending on parameters that are, partly there's the moon phase, the sunrise, sun position, but the wind, weather conditions are always changing and rendering the work in a different way. There's also computer vision systems that analyzes the position of people in space and controls the virtual camera in that space. So the point of view is a shared experience that determines the point of view on the space. Here it was at night in Lyon, so the point cloud is almost invisible, but you can feel the phenomena happening. So there was a storm, a lot of wind, and you can barely see the architecture. So I'm always, a lot of times I'm working with extremely detailed data and I'm rendering them almost unreadable. I did a whole body of work also on computer visions for autonomous vehicles and robotics. So this is a segmentation network. The first layers that decodes the environment and analyzes where's the sky, the road, if there's vegetation, stuff like that. So yeah, I'm interested a lot in computational photography and operational images. So how images, well, a lot of images today are made by machines for other machines instead of being seen by humans. So this is an optical flow system that try to estimate the future position of objects. Same system, but the car is contemplating the St. Lawrence River and kind of analyzes where the waves are going. Also, this piece is called Mapping Machine Uncertainty. So to the right, the black spots in the image are parts of the image that the system can't analyze. So I did a heat map in the city. I was holding an exhibition of the locations in the city where the machine was the most confused. So yeah, it has some scientific value, but it was completely, an artistic project. And yeah, it raises a lot of questions. Will the urbanism or architecture be transformed for autonomous vehicles and stuff like that? So at the same time, it's a very scientific parameter, the machine uncertainty, but it's strictly poetic in a way. So this is a work, well, I had a residency in 2019. I was in Mexico City and I was really fascinated by the relations between trees and the city infrastructures. So the sidewalks, the roads were kind of uplifted by the roots of the trees in the city. So I did a piece where I 3D scanned one of these trees interacting with its environment. And here you see it, the image is kind of flipped upside down. So you're kind of gravitating around the hole, but in fact, it's just a 3D model that's flipped. And then you enter inside the trunk of the tree and you navigate through its branches as if they were roots. And at a certain point, you understand what's going on. Another work, I was again fascinated by the trees that were growing on that huge boulder and kind of englobing it. So I 3D scanned it once more. And it's like a radiography of that relation between the vegetation and the rock. And you can really feel the adaptivity of trees and vegetation in general. So yes, which leads me afterwards to another piece where, of course, it's always the surface of objects. And for that piece called Cryptocrystallin, I was interested to render visible the inside of a rock. So that's a geode, an agate. So it's a rock that's formed by volcanic gases. And inside of the rock, there's often crystals. And you can feel the volcanic activity that built the rock through the surface of the rock. So there's bubbles. So an algorithm reconstructs the interior of the rock, and you're kind of navigating through it with a depth of field effect. So it's like a slice, but a blurry slice. So at the same time, it evokes the energy that was used that it took to form the rock. Also, that was in 2017. I started 3D scanning coastal landscapes. That was in Newfoundland. So I was in the water walking and 3D scanning the cliff. And I've been using a drone since 3 or 4 years now. So it facilitates that work. And what I found interesting here, is, of course, the relation between the land and the sea. If you try to 3D scan water, probably a lot of you have tried that, it's always moving and it reflects water. So it produces glitches that I found really interesting related to coastal erosion, how the water is transforming the landscape of the shores. So I did a work like this, like when I amplified this effect. And I also developed a piece called Erosions, which has different iterations. That was a year ago in Oboro. So what you see is just a little part of the model that the person is gonna explore with the headset. What you see, in fact, is a virtual camera that's gravitating around the headset. So when the person has it on its head, it kind of zooms in on certain atoms in a way that constitute the landscape. Maybe I'll add a little bit of sound. And yeah, you just have a very abstract understanding of what's going on. At the same time, the person is building up the soundscape when he has the headset on his head. And what the person's, well, I like the different relations that it establishes, because the person that has the headset on doesn't see what's going on outside of this virtual space. This is the virtual space in which I amplify certain geomorphic characteristics of the landscapes that I scanned. Here, there was like folds and the geology, and the stratas were like tilted to 90 degrees. So you could see different stratas on the ground of different type of rocks. And that's another one. There's just a little slice of the landscape that is revealed. And at a certain point, the images stays inscribed in the space. So what you see now is like the person is painting the landscape with stratas from the scan I made, but the movement of his or her head forms a new geology that's always changing. So every scene that I explored, documented, 3D scanned, it's explored in a different way that echoes the geological characteristics or the phenomena at work. This is just to give you an idea of what's happening. The person is seeing this, and outside we're seeing that. So just certain parts of the image. And by using two projections, I find it interesting to kind of evoke, you know, in 3D software, you have a front view and a side view. So that's a similar thing that's happening right there. So you see the front view of the geological formation and the side view. And I also like the fact that the headset can be used as a joystick, not necessarily put on your head. So you have different level of experience with that device. Because I'm not a big fan of VR in general, the experience it allows, but I'm really interested by the different possibilities that can, you know, result from using that type of technology. So voila, coming back to the research I've been doing in the last months. So in May, I had that exhibition of the piece that you just saw. That was the fourth iteration of Erosion. So the exhibition was held around here, and I spent the rest of the month in the Atlantic provinces documenting different forms of erosion, different landscapes, different geology and ecosystem. So one of the things I wanted to try this summer was to explore different ways of 3D scanning. So this is a Gaussian splatting technique that maybe some of you know. So it's similar to photogrammetry, but instead it's kind of made up of millions of circles that are stretched, and their opacity and color change depending on the point of view. And yeah, well, of course, there's also glitches happening. Here you have the feeling there's a big hurricane going on. The water is all amplified and distorted. We find that interesting. Same thing here, you have that feeling of waves. But one of the main aspects that interested me here was to discover different landscapes, different ecosystems, different geology, and all the communities are affected one way or the other by erosion. There was a big storm at the end of 2022 that provoked a lot of landslides and destroyed several parts of the coastal areas. So last year and the year before, a lot of communities try to figure out ways to prevent erosion, and I'll get back to it later. But most of them are now using vegetation instead of installing big rocks or blocks of concrete. So yeah, one thing that I find interesting everywhere I go is the relations between the vegetation, the soil, and the geology. That's always different from one place to the other. So voila, that's kind of an inventory of different places I've been and the experimentations I've been doing using the Gaussian splatting technique, but I tried also neural radiance fields that I'll talk about it later on. So yeah, this is another place in Nova Scotia to the north of Cap Breton, and the trees next to the very abrupt cliff. I found that really interesting. And this location is at Prince Edward Island, where there was a lot of roots coming out of the soil on top of sandstone, I think is the word in English, grès in French. And yeah, you saw parts of the landscape falling into the sea. So I have a lot of data. You're just seeing a part of it. And I'll speed up a bit. So at that location, I know the community was trying to figure out ways to prevent erosion from being more damageable. There's a lot of houses that are really close to that cliff. I'll accelerate a bit. Last one. Okay, here it's in New Brunswick. So there was also trees that were falling down from that cliff. Okay. And I'll just show you some, I'll accelerate a bit. Okay, so yes, I was interested by the different ways people are trying to prevent erosion. As I mentioned, a lot of communities are taking action, and a lot of them, that's Attention Fragile. They are on the Magdalene Island, Île de la Madeleine, and they're using Amophile à ligule courte to do this. I think the simple term is, in English, it's much simpler. It's seagrass. So a lot of communities are using native plants to prevent erosion and to protect the shore. So yeah, I was interested by the Gatineau River. I don't know much the Gatineau River. So what are the different problematic, if there are problematic issues? Maybe everything's fine over there. So yeah, I'm looking forward to discover what's going on. And I know, yeah, I went to that website for the protection of the river, where they mention different shoreline protection techniques. Get to it. Also using native plants. I'll accelerate. Okay, so the website has a lot of information. I will go through it, but it mentions a few of the plants that are recommended to use, and the different interactions with the different types of plants, and how it could work out for people. So this is a list of different plants they are suggesting. Accelerate. Willow is not part of that list, but there's some information that I found about the properties of willow for the protection of shores to prevent erosion. So yeah, I kind of did some research about different systems and techniques that are used and different types of root systems. These are, to me, very fascinating images and very inspiring. That led to another piece that I'll talk a bit later on, piece that I'm developing. This is information about the willow and its properties to control erosion. So yeah, I was curious about that, and I'm looking forward to be at the farm to see what you're doing. So this is a willow tree and different techniques. So I accumulated different data. And yeah, the other work, I'd say the main work I've been working on this summer, well, experimenting with, is that tree that is located on the north of Cap Breton, almost in the middle of the Gulf of St. Lawrence, that's holding to a cliff by its roots. And you can see that it has a lot of character. It's in a very hostile environment, I guess, during the winter time. It's up a cliff, just to situate it, it's about here. So it's almost in the middle of the Gulf of St. Lawrence. And that cliff is pretty high, at least 20 or 30 meters, and it's quite abrupt. So I've been experimenting with neural radiant fields. What I find interesting in that system is I can access different states of the system and different layers of how it constructs the 3D scene. So here you just have a few steps of training of the system. So it does a very blurry, low resolution image. And the more you train it, the more it becomes detailed. So I'm interested in the fact that I can access the different levels of training of that system. So, and yeah, it's really inside a cube and there's a lot of noise in it, but in a way, I find it more interesting than Gaussian splatting. So here you have a more detailed 3D model of the scene, and here the different layers that construct the scene. It's always the same camera movement as kids. I oftenly work with loops, and I find it interesting here to always have the same camera movement exploring the scene. So that's kind of weird. And to reveal different states or different forms of encoding or data distribution in that space. Always the same movements, but here it becomes very abstract. It's made up of cube, and I really like that one. It's just kind of a depth map. Every corner of that cube has a different color, and it reveals the depth of the scene in different ways. Same technique, but with a different form of visualization of the data. So it's a lot more blurry, but very colorful. It's more, this really makes me think of the dusk, what the dusk evoke. It really looks like a sunrise or sunset, and it's really abstract at the same time. So what's more, this is the model itself. And what I'm interested now would be to go underneath the surface, like I did for cryptocrystalline, what's underneath the surface. So of course the neural networks evokes, the brain cells, but also roots. So, and how can I access what forms the images and what would be under the ground? So that's just another form of visualization that you're seeing. But I like the fact that I can access all the hidden layers of AI in a way, a theme that's been explored before. So that's the cube that contains the space in a way, and it's different type of visualization. So sometimes it becomes very abstract and minimalist. So you just have the outside point of view of that space. And here are the images and how it's decoded, well, encoded, decoded by the system. When I think about the hidden layers, what's underneath the landscape or the image, can be an interesting path to explore. And this is a Gaussian splat of the scene, which is a lot more detailed than what you saw of the neural radiance field. So I could maybe mix both and work on something underground, the roots of that tree that we don't see, but also the soil, but maybe in an abstract way that recalls the construction of the image. I'll accelerate a bit because I have a lot of screenshots. But you just, it gives you an idea. It's quite detailed. So if I want to mix the two, or maybe even add, the photogrammetric models I did, because I also have very detailed point clouds and meshes of that scene, could be a possibility to then afterwards go underneath the surface of things and kind of not really reveal what's under the surface, because I can't really access it and it would be very abstract, but to use this as a way of showing how the image is constructed. So these are just graphs explaining what the neural radiance field is. So the different processes that are used and how the data is encoded. And to me, it really evokes, as I mentioned, of course, the biological neural network, but also the root systems. As you can see here. So voila, this is pretty much a path that I'd like to follow. And I'll briefly conclude with what I did in the last week. So I spent a month in Baie-Saint-Paul. It was the symposium, International Symposium of Contemporary Art. We were 12 artists. I won't speak about all the projects. So Baie-Saint-Paul is 4 hours from Montreal, more in direction of the Gulf of St. Lawrence. There's an artist called Gilberto Esparza. Maybe you know him. He's well known. He did a work that is a floating structure that you can see here, that with plants and a pump, so the water is pumped by probably using solar energy, and it's distributed in the structure, and plants filter out the water, and there are some plants that grow edible plants at the same time as the water is filtered. So I thought that work really evoked, I'll go back to it, found really interesting relation, that work with our project. And he's also including elements that mimic the sound of birds using water and wind. So yeah, I found that was a quite interesting project. So for me, I was going, Baie-Saint-Paul is right here. It's in the middle of the estuary of the St. Lawrence. So the parts, that's the river, the estuary, and you arrive to the Gulf right here. And I was thinking about working on coastal erosion right there because there's some problematic issues. But that area was formed by a meteorite impact. Well, the topography is a lot revealing of that impact. So there's a valley here, and another valley there, and Baie-Saint-Paul is right here. So I kind of diverted my attention from the seashore to that valley, and there's a river that goes through it. And all of because of the topography, there's mountains on both sides. All the water condenses in that valley. So last year, there was a major flood that destroyed a lot of houses. And there's also firefighters that died. It happened at the beginning of May, just at the end of winter time. So the ground was frozen, so it didn't absorb water. and all the snow from the mountains kind of melted at the same time that the rain came into the valley. So the level of the water rose by 2 or 3 meters, maybe even more in some areas. And there's still signs of what happened that day. So I thought that was a very sensitive issue. So I wasn't too sure about how to approach it as a, Montrealer arriving somewhere. There's been a catastrophe. I tend to be very cautious on my way of approaching this. So I explored the valley, the Vallée du Gouffre. Gouffre in English means chasm. It's like a precipice. So I 3D scan using neural radiance fields, different parts of the river from the estuary of St. Lawrence up to the forest. So I did 3D scans, but also sound mapping using omnidirectional microphones. So I have a lot of data. What you see are prints of photogrammetry that I did from the area, which is highly detailed. That's like 1,000 pictures. The other one is almost 2,000 pictures combined into one. And this is the Rivière Le Gros Bras that at the confluence of Rivière du Gouffre. And the water level was super low 2 or 3 weeks ago. So it was really a contrast with the flooding of last year because the water level was really dried up. So there's a mix of very detailed information and blurry elements to it because all my attention was on the river and all the agricultural lands around are kind of blurred up because I didn't have much information on it. So as I said in the beginning, I like to mix up very detailed information with blurry and incomplete images. That's the estuary, that's the beach at the end of the city. That's in the forest, the meanderings. So yeah, I'm really interested by the meanderings of the river because you're quickly lost in space in a way. You don't know what's coming up at the next corner. And yeah, as always, I find fascinating to 3D scan water. Here you can see kind of almost like waterfalls in the middle of the river. Here you have holes and the water seems to be going down in it. So yeah, I didn't want to do something too catastrophic. So it's really colorful and calm and contemplative. And yeah, that was, yeah. What I found also very interesting is that all the information that I was using for my prospection in a way before going somewhere, the Google map data was completely changed. Where there was a spot to go fishing, now it was a beach. The place there was an agricultural land, it was now part of the river. So all the landscape has changed in a year. So it really reveals how a river is alive also. The meanderings is a good hint of this. Yeah, voila. So it was a really intense month of me exploring the space and discussing with people. I also, yeah, cameras underwater and accumulated a lot of data. So yeah, that's pretty much what I'll conclude it on. Yeah, here I really like the vibration of the rocks in the water. You really feel the neural network working here. So these are kind of elements I discovered. It's mostly experiments because we had only 2 days of by week where we could, go out. The 5 days we were talking with people. So it was a really intense moment for me to get data, but I'm still working on that piece. Just wanted to conclude with that image, which kind of combines my main research themes or elements. So yeah, erosion, root systems, and different types of volumetric reconstruction or deconstruction of space. So yeah, voila, that's my resume of what I did in the last weeks and months.
Thank you for sharing. I mean, yeah, then my question was that the AI generates the images of the rocks or any root systems and underneath the ground.
Yeah, I'm sorry, I didn't
Um,
understand.
the AI can generate the rocks or any images of the natures. Through your the images that you take.
Yeah, well, it's reconstructing images that I took in
Mm.
pictures. Sometimes the glitches provoke new images, but now it's not really generating. Well, I tried something, but I really wasn't impressed by generating new images from, I should have included this, from some coastal erosion, well, the erosion of the river. I fed it with two images I made, and I made the system imagine the rest, and it wasn't very conclusive.
Mhm.
And that, yeah, this is even when I was describing calm scenery, just I'm describing what it sees. It fell into kind of a catastrophic type of vibe, with very high waves and the construction of the landscape instead of being a continuity of what I did. So that was kind of weird. I should have included that, but I put it aside because for that project, I didn't want to have something too intense because some people are kind of traumatized with what happened last year. So I was more looking for something more calm and contemplative. But yeah, the next step would be to generate what's underground, and either by 3D modeling simulation, or by using neural network. But I really want to reveal also the hidden layers of AI or the process that reconstruct the scenes that you're watching.
Okay. Because Erica's question was that could you explain about this neural gradient process, right?
Oh, sorry, I didn't see a question.
Yeah, on the chat.
Can you give a link that explains? A link, yeah, I can share that. Yeah, but I'm not able to explain it correctly in English. Yeah, I can share that to you. So there are different systems that exist. Some are, and the one I found was really interesting because you can work with different levels of training of and different forms of visualization, and that in itself makes it more interesting to me, well, for certain aspects than Gaussian splatting that is more precise, or photogrammetry. You can really see what's going on under the hood in a way, and make something really abstract from these scenes. So I'll share that to you. Yeah, go ahead.
And actually, oh yeah, Erica.
Hi, Francois, that was really interesting, and I'm now super curious about this neural radiance process. Does it invents what is underneath, right? Because or are you doing a certain type of scanning that penetrates?
No, it doesn't penetrate for now. But what I'd like to do is, to combine different techniques and try to. Well, of course, it advanced, but it's mainly glitches. The way it does that cube.
Yeah.
It's kind of, well, I interpreted, I don't know if that's the right word, as glitches of, there's also parts of trees up in the air, so, but very blurry. But yeah, I like the fact that when the neural network generates the image while you look from different angles. So the specular aspects and reflections are more interesting or complex than if it would be a photogrammetric 3D scan, or even Gaussian splatting is really minimalist. It's just plenty of circles that are flat that are you see from different angles. But yeah, that system, I'm sorry, I lost my first,
no worries.
I was going. So no, it's not, well, it's inventing, but it's not really inventing what I'd like it to invent. And no, I'm not using a technique that goes underneath, as I did with a cryptocrystalline work, generating the inside of a rock. That was done with a 3D software that kind of reconstructs a structure inside of it. So I would have to do something like that, or to use AI to generate some images.
Or ground penetrating radar.
Yeah, in a way. So yeah, but I'm mainly interested to, it's not a metaphor, but it's a way to talk about what generated that image, all the what's hiding under the surface of these.
Okay, I got one more question, if that's okay.
Yeah.
So when we're watching the image generation, it's live AI production, like it's a live generation.
From the data that I
From the
gave
data.
the system, yeah, like 300 images, and that's instant nerf NGP, I think the system I've been using. But as Luisa wrote, Luma AI, you can go on the Luma website. It's a way to, you can do some Gaussian splatting, and it can also generate nerfs as renders. So yeah, I tried two different systems for the Gaussian splatting. Luma is one of them. For the what you saw is kind of the preview, and the other system I use is called Post Shoot, I think, which can go to a much finer detail. So the cliffhanger images you saw at the end, which were a lot more detailed than the work I did on the coast of, all the compilation of the different Gaussian splat is a lot more detailed, the grass and all of that. So, but it's very, it's one is web-based and the other is installed on your computer, and it runs for, hours and hours to generate. You can train it for 100,000 steps, and it's gonna take the whole day. So yeah, voila.
Yeah. And another question was that actually you when I discussed about the workshops, then we were a little bit hard to find the right location. So Marie and Bob, could you recommend any specific locations that have any problems, any environmental problems, or any specific locations we can explore the root systems? Yeah, near the farm.
Yeah, we were recently at a climate action committee at the municipality, and there's probably there's someone there who really specifies in erosion and kind of the water table. So she's someone that we might just be able to connect with maybe this week, or maybe it's someone we could arrange for you to meet and to identify a few areas. Yeah, I think I was also just curious with the drone capture that you were doing, like what's your range with the drone?
I can go up to 3 kilometers.
Okay.
But it's always better to keep sight on it.
Yeah,
so
that's what I was wondering.
It would be. I had a very interesting experience this summer. It was super hot, like 35 degrees, and I was along the river, and all of a sudden, my phone that I use as part of the remote overheated, and the little thermometer that appears.
Yeah.
And we must shut down. I was controlling the drone, and everything was kind of bloop. Your phone is shut down for the next, you don't know how much time. So it was hovering somewhere in the forest while I couldn't control it anymore. So it was a bit of a stressful experience. But anyway, after 10 minutes, I put it in the shade, and it came back to life, but it was a bit stressful. But yeah, I have a lot of range, and you can go up to 125 meters also. So yeah.
Because I'm just thinking about the crown lands behind the property. There are lots of lakes that feed into streams that feed into, like, there might be some interesting capture that could be done there, but it would be a full day excursion if you wanted to hike into that into those areas.
Yeah. Sorry.
Oh, no worries. One of the things that we'll cover in the workshop that I'm going to give is the beaver landscape on our property. So we have a large beaver pond where they stayed for quite some time, and then they moved downstream, sort of impacting smaller areas in other ways. And then the farm next door recently was purchased, and the landscape was changed, and it's affected the water in the beaver pond. So we'll be working on like exploring ways of remediating that, and then looking also at what you can and can't do to a beaver or a beaver landscape, and why. And it's largely around municipal infrastructure and not actually care of the land or the ecosystem in any way. And so trying to creatively find ways to work within those boundaries. And one of the few things that you're allowed to do around water on your property is plant native species. So planting willow is one of the things that we can do to, remediate the land from the damage from the farmer, but also protecting infrastructure without, necessarily. Well, there is very little that you can do, but without necessarily having to remove animals. Yeah, so that area, I think, is an interesting one to look at, and we will be looking at that area. And then I think there's like so that sort of starts at the far end of our property, and then the stream runs through the property, doing some interesting things. And the landscape around it is harder to hike, but it is really interesting landscape. So following that with doing some drone capture around that would be really interesting. And we actually have a neural radiance video of a different part of the creek, which I love. I worked in VR before coming here and was always thinking, like, how can you represent the land here in a way that feels as calm and meditative and, as being in the land. And I found the neural radiance was as close to the natural magic of being in the space, even though it's very different, but it's the closest that I've seen but I've never seen these Gaussian splats. So they're very interesting too. I really liked
what the reasons the neural radiance fields appear maybe 3 years ago, and the Gaussian splats were invented before that, but for the last 2 years they've been very popular because it's a lot quicker and lighter than to generate the neural radiance fields. But both of these techniques, I didn't really want to use them in the past because they have a very distinctive aesthetic. You look at it, okay, I know it's been generated by that. So what I find interesting now, 3 years later, is like the big thing. 3 years ago everyone was trying it, and it had that. But what I find interesting now is kind of to be able to deconstruct them and see what's underneath, what you mainly see as the render.
I think the glitches are sort of interesting hallucinations to me, and I think working with them is really interesting. What I liked about this scene that you were looking at with areas where there was erosion on the cliffs. My childhood home was on in a landslide zone, and it was a happy place, and so it was sad when we had to leave. But when you're looking at it with the camera and then you fly through the rocks, it gives a really like uneasy feeling of like you thought it was solid and it's not solid. And that's I don't know. I thought that was very. I know you said you're trying to be mindful of not re-traumatizing people with the work, but for people who weren't in it, it's effective at giving that sense.
Thanks. Well, thanks for talking about the beaver pond, because that was another element. The Gatineau River, the root systems of willow, I'm curious, and the beaver pond. Of course, there's relation between trees, water, and animals. So there's something that I'd like to explore on that side too. So I'm curious to see what's going on the land.
Right. You arrive early in the farm, so you can have some time to explore the beaver pond and the Gatineau River, right? So and anyway, thank you for today's the presentation.